Thank you very much for joining this talk. I'm Nicolas Mellado, and I will present you our project called 3d-Acquired Research Dataset. That's an ongoing project shared between the Institut de Recherche en Informatique de Toulouse and Archéovision in Bordeaux. So, this project focuses on 3D acquired data, and today it's very easy to get 3D data using your phone, using devices, cheap devices. But the problem is that it's difficult to get high quality data. And mostly because it costs a lot of money to do that. So first you need dedicated hardware, you need cameras, 3D scanners, you need drones sometime. Then it takes time. So you need to have people going to the object or the building, or the location where you need to do the acquisition, and we need to spend hours or even days to do the process. So you need to have a nice weather, you need to have a nice lighting, you don't want to have people jumping around the scene when you do the acquisition, and so on and so forth. And then when you spend all of this time and you come back to your place, you need to have your powerful computer with a very expensive software. You need to have skilled experts to process the data, and so on. So because of that, it takes time, it costs a lot of money, and we as scientists are lacking access to this kind of data. Because again, the question is who pay for it. So of course there are some data set available out there, but most of the time they are very specific to a given application case or a given device. So for instance, you get this very nice dataset, the ABC dataset that has been provided like last year, that is composed by thousands of CAD models, and you get ground truth for feature line extraction and so on. The problem is that if you want to do something else, you want to analyze or process other kind of object, you don't have them. So you could also have access to robots or autonomous driving datasets and so on. Recently, you got the textured mesh dataset that has been released, where you get a statue and a sandwich at the same place. So it's less specific in terms of objects. But the problem is that the content is not representative of the quality of professional 3D models, because they collected the data from different sources, and so the objects are composed of few millions of points, while in production quality models are composed by hundreds of millions of points. And also you don't have any idea about all of the acquisition and processing context. You don't know what software has been used, you don't know what is the true data that has been acquired and what has been processed. You have no idea. So you just take the model as they are and you use them. So we propose here, and try to propose an alternative to this. So we want to release a dataset where you find data that has been acquired by professional of 3D acquisition. So we use professional hardware and software, we combine different modalities, and we release all of this. Also, as professionals tend to do some very tedious process to get high quality models, we also want to make this available. So each time we have some data, we also, for each process that is applied on the data, we release a description of this process and the outputs of it. And all of this will be shared for research purposes under Creative Commons. So to do that, we make up this team. So we are at two locations. So I'm in Toulouse, and the other are Archeovision in Bordeaux, which is a lab specialized on the use of 3D data and for cultural heritage applications. So we currently have Quentin Marcadet, who is the intern doing all of the acquisition right now, who is supervised by Loïc Espinas and Pascal Mora, who are experts on acquisition and reconstruction and processing of 3D data for cultural heritage applications. We have Bruno Dutaillé, who is an engineer in charge of all the environments and tools you need to do all of these processes. And we have Sarah Tournon-Valiant, who is working on all the tools to make all of this information available to the public. And we have Xavier Granier, who is the chief scientist of this of Archeovision, and who help also on the computer science part with me. Okay, and in addition to all of these nice people, we also get access to the hardware and software they daily use for their work. So we will use drones, fancy hardware to do the acquisition, and the processing, reconstruction and processing following all the process they do on the daily basis for cultural heritage applications. Same for modeling. For the storage, we use the services provided by Humanum, which is a TGIR specialized on cultural heritage application, and all of the sharing the data will be done using ArcheoGrid, which is like a web portal for sharing data for cultural heritage applications. So we get all of this in this project. So now I will describe you our dataset. So it's an ongoing project. We're still working on it, and I'm trying to describe, what kind of data, so you get an overview of what we'll share, and so we can discuss it later during the QA if you want. So first, our goal is to provide different assets, of course, but more importantly, we want for each asset to have multiple versions, and this is very important. We don't plan to have hundreds of assets, maybe more like a dozen, but for each of the assets, we'll have a lot of different versions that can be all used for evaluating algorithm and processes we do as a researcher in computer science. So for instance, you will have point cloud. You will get photo for photogrammetry with the masks that are designed by professionals. You get a clean point clouds, clean meshes, low poly meshes with high quality textures and UVs, and so on. And all of these will be enhanced by metadata that are described in a format that can be processed by Python if you want to do batch analysis or processing of the dataset. So just in terms of terminology, the version of an asset are called units, and all the metadata are stored into a JSON file. So I will now present you the JSON file. So for an asset, what is an asset? Is something that's a physical object. So here we have an example where we have the famous fancy asset, which is owned by the Louvre. You can get more info about it online, and yeah, this file is just describing what is this fancy asset. And then that's your entry point, and then you can have access to all the units that are available that are containing the true data, and these units are split into I mean, there are currently two type of units. The acquisition units that are outputs raw materials, and the processing units that take the output of another unit and produce a new output. So what we call a unit is something that is describing a process and that generates data, and we share the metadata about the process and the output data. So the way it works is that you get here you have an acquisition unit. So it's a scan that has been done using a Faro arm, and so you get a description of this unit, of what it does, and all of the details about the parameter setting of the scanner, for instance. And you get a list of all of the outputs that have been generated during this process, and then you can access the files which contain the actual data. So all of the acquisition units will be described that way, and the processing unit follow the same structure. What will change mostly that the input field will now list IDs of other units that are took as input for the processing. And then again, you get a list of output with optionally a description of what's happening. So here, for instance, it's a registration unit where all of the point cloud and meshes that have been acquired for this asset are registered in a command frame. Okay, so now I will, I mean, that's it in terms of metadata, and now I will present you some of the models we currently have and what we plan to do for the next steps. So the first one is the Lady of Elch. So this one that's a statue, and we just wanted to have this kind of object with lot of, you have some parts with a lot of details, some other parts that are very smooth. You have like symmetry, you have a kind of complex shape, and we want to use it for to evaluate different acquisition processes, and also like many geometry processing algorithms, feature extraction, and so on. So right now we have two acquisition modalities, the Faro scan arm, which is interesting because it outputs a line of points like that. So it's very anisotropic sampling. And we also have photogrammetry, and we'll plan to have another laser scan with a different sampling pattern to get a different description. And so you can then take all of these point clouds and run your algorithm on all of the versions and check if your fancy algorithm is working properly on different point clouds showing the same geometry. So it's a multimodality thing. In terms of units, we have 6 acquisition units, like the different views from the scan and the photos for the photogrammetry. And in terms of processes, we get some meshes that are generated by the scanning software in different resolution. And we also have the photogrammetry reconstruction using different softwares and configuration as well. And we plan to add low poly meshes with nice UVs, and also maybe a quad version of a model you could use in like games or augmented reality or whatever. So this is an ongoing process. Then we have the skull of this very small bird. So this one is very interesting because it's small enough so we can fit it into a microtomography system, and we can acquire its volume, and then so we'll release this volumetric data alongside with photogrammetry and laser scanning. And so here again we have a multi-modality dataset where you can run algorithm on different version, and and check if they works well. And the nice thing with the microtomography is that it gives a ground truth data for instance, photogrammetry reconstruction, which is very difficult in that case because the bonds are so thin that they are almost transparent. Similar objects, but with different property, is this very small bone, which is so it's like maybe 3 or 4 centimeter wide, and here there is an engrafted pattern on it, so it can be interesting for evaluation of the extraction of small geometrical features. And here again we have the microtomography as a ground truth for comparison purposes. So we plan to add more units to this. So we just started 1 month and a half ago, and so we want to add registration units to put all the data in the same frames. We want to add cleaning units where the point clouds and meshes are cleaned by experts, and also, like I said, like meshing, UVs, and texturing units. Also, these 3 assets are not enough to be representative, so we want to add the full acquisition of a building that using drones, and we'll also try to release a mesh that has been modeled from the acquisition by an artist, and orthophoto to describe the facades and so on. We'll also have an acquisition into a stone pit, which is interesting because it's a big structure with walls that are not straight like what you have in a building, and it can be very interesting for the analysis of photogrammetry algorithm to evaluate the low frequency noise you can have and the error accumulation you can have during the registration. So for that we'll have a laser scanning of this place with which will be corrected by professionals. And then in 2 weeks we'll have an acquisition of object with complex appearances, and again with laser scan and photogrammetry. So I'm reaching the end of this talk. The take-home message here is that we're working on a new dataset that combine acquired and processed data that is generated by experts using state-of-the-art hardware and software. We provide all of the metadata for scripting, and all of this can be used as ground truth for many algorithms in computer science. And you could see the different modalities either to define ground truth or to check the robustness of your algorithm. And all of this will be shared under Creative Commons. So thank you very much for your attention. You can access the website of the project, putting the address on the top of the slide, and the data will be made available in the upcoming months. So thank you very much, and let's meet during the Q&A session.